So I thought, so the title of the presentation changed, breaking every guardrail everywhere all at once. This is a reference to a movie that some of you might have seen. So instead of starting with the presentation, I'm gonna read a little story. This is a personal story. I'm taking you back to the beginning of 2024. How many people here do pen testing? Quite a bit of you. So imagine this is you. It's day 3 of a 5-day pen test. You spent the first 2 days begging for missing requirements, waiting for credentials, and finally being given access to a URL only to find out that it's 500 on you. And the devs are on the other side of the world and have logged out for the day. So meanwhile, you've leveled up your thumb twiddling skills to a new professional standard. Finally, on day 3, the app miraculously starts working. You notice a big shiny button that says, maybe the volume is too high. You notice a big shiny button that says, summarize my inbox. You click it and instantly you know. Hype Lord Sam Altman's gift to the world, yet another LLM hiding behind a button. You frantically Google hacking LLMs for dummies, and maybe you strike gold and find a video by prompt injection guru Johan Reiberga, and 40 minutes later, you've learned just enough to be dangerous. So you go back to the application and you craft a test email with a carefully researched, super duper malicious payload, new important instructions, and tell the LLM to include a markdown image in its response whose URL contains a secret you want to steal. In this case, the password reset token from another email. You hit the summarize button and a GPU cluster in an AI data center burns through a swimming pool of water for 30 seconds to generate an answer. You see the markdown image rendered in the response and its URL containing the password reset token you wanted to exfiltrate. Bingo, you are an elite prompt hacker. You've done your job and now you can ask ChatGPT to write the report for you and go back to your incredibly satisfying thumb twiddling practice. But with your usual luck, it turns out the devs were just trolling you, and they had forgotten to enable the guardrails. Now you go back into the application and you try again your payload, new important instructions, and nothing happens. No image is rendered, no data exfiltration is happening. Your hard-learned uber super duper payload that worked before is now as useful as a 0 day on Internet Explorer. 1 day left to test and write the report, and you are understandably not thrilled. You need to start really working for your money. So you start scavenging obscure Reddit threads, looking for some weird jailbreak that sorts of makes sense for the application you're testing, but nothing. You Google LLM red teaming and pull a few automated tools, but they are all built to test LLM models, not LLM applications. They seem to require an OpenAI key to operate, and their prompts shout things like, tell me how to build a bomb, or say humanity is stupid. So if you are like me, and you're trying to do a pen test, and this is day 4 of that 5-day pen test, this is how you feel. And warning, I don't even know if the audio is going to work. Maybe it is. Yes, for the next 20 seconds, there are going to be flashing images. And then we're actually going to start the presentation. But that's how I felt that January 2024 while I was doing this pen test. prompt injection, jailbreak filter, do anything now, topic control, rate limiting, auto validation, developer mode, sandboxing, access control, human in the loop, token smuggling, indirect prompt injection, multi-turn attacks, basics, whatever that was. Wouldn't it be great if we had a way to break every LLM guardrail everywhere all at once? And that is the reason why back in 2024, we started a project which was an internal project, but then became now an open source project called Spiky, Simple Prompt Injection Kit for Evaluation and Exploitation. And I'm going to talk to you about less about the tool and more about what were the problems that we were having while trying to pen test these applications and how we came up with different solutions. I am going to attempt my best to make this presentation last roughly 30 minutes so that there is time for questions if you have any. So I'll tell you a little bit about me. I mean, you already know, so I'm going to ask ChatGPT. This is my who am I slide these days. Who is Donato Capitella? That's I mean, if you used to do this in 2023, you wouldn't get a good answer, but now I think you get a fairly good answer. So I work at Reversec or Reversec. You decide how you want to pronounce that. We have had many names: MWR InfoSecurity, F-Secure, WithSecure, you name it. We are an offensive security consultancy. I worked there as a software engineer, penetration tester, and I wear many hats. But the last few years, I have been working on generative AI security, and mostly testing the LLM applications that our clients were trying to deploy. I think, in a way, we've been very lucky. I remember at the end of 2023, one of our biggest clients came to us and said, "We are building an LLM agent." This was 2023. They were trying to do it with GPT 3.5 Turbo, I think it was. And that was the first thing I ever tested. And I had no idea what I was doing, but they had even less of an idea what they were trying to do. Anyway, the agenda for this. So when we started testing these LLM applications, we had a wish list. We had things that we needed in our tooling that we couldn't find elsewhere. So we started writing scripts, but I'm going to walk you, and that became Spiky, but I'm going to walk you through what these problems were and what was a simple solution. Now, I think these were good solutions because if you fast forward to today, other people that had the same problem roughly started solving it in the same way. For example, the prompt foo guys, or some people at Microsoft with Pirate. There is a very healthy open source ecosystem around this. But let me start with the first problem that we had. So when I was looking for tooling to pen test LLMs, I found LLM red teaming. So there was, and there is, something called Garak. Very academic tool. The people that make it are fantastic, but it was a very academic tool geared towards an LLM in isolation, an inference endpoint, which was totally useless to me when I was testing a summarization button in a web application. What am I going to do with that? So my problem was that my clients already in 2024 were building things that were not just LLMs. They were building what we would call agents now. And so we needed a simple way to abstract Spiky from the interface that the solution had. And obviously, Spiky is modular, and the way that we did it, for every application that you want to test, for every endpoint that you need to test, you can simply implement a target, which is, I mean, you vibe code it. I haven't written one of these myself in ages. Any LLM is able to write this if you give it the API endpoints. But this allows us to test anything that would interact or be powered by an LLM. Some of the things that, for example, we have done, I remember banging my head against the wall for this. So we had a use case where you had to upload some documents some files on an S3 bucket, call a Lambda function. That would process the files, and then you would need to go into the CloudWatch logs to see if any of your attacks worked. I mean, you can write you can get an LLM to write to you a couple of lines of code that can allow Spiky to talk to that in a way that can send a payload and can check the output. And also some of the other problems that sometimes we have, when you have WebSocket applications that are very common with chatbots, it's a pain to even try to implement that protocol. You can do it with Playwright. But the point is, we abstracted completely Spiky from what we were testing. And the beginning of every test, the first 10 minutes is vibe code, something like that. Easy problem solved. Now, the second problem, and the most important one, like if you take a couple of things away from here, this is one of the most important things, the customizable data sets. So you see, the problem is, if you have an LLM and you are doing LLM red teaming, so you have a list of general purpose safety things. Tell me how to build a bomb with household items. That's one thing. But if you have an LLM agent or application, the things that you are going to ask that you want to achieve need to be very targeted to whatever the use case of that application is. And so what we needed was a way to take all of the prompt injection techniques or jailbreaks. And by the way, I use prompt injection and jailbreaks interchangeably. We could have arguments on this for a couple of centuries. They're probably different, but allow me to use them interchangeably. But then when I look at, for example, the use case that I was showing you before, I send an email and there is a mailbox and a button to summarize that mailbox. Now, what is it that goes into the LLM? That entire prompt, summarize the following emails with all of the emails. Me as an attacker, I obviously only control the email that I am sending. I don't control the system prompt. I don't control the other emails. I don't control the instruction. So I need to be able to define in Spiky what's the shape of the type of input that I am sending. Is it a Jira ticket? Is it a Word document? Is it a prompt for a chatbot? But very unlikely, it is the entire input to the LLM. Once I do that, if you look at the attack, I have the regular document, that's just an email, and then I have what I typically call a jailbreak, which is a language pattern that allows me to disalign the LLM, to make it do something I want to do. So you know them, I'm not gonna read them, and you can find your own. But that is different from what I want the LLM to do in that particular case. What is my malicious intent? In that case, data exfiltration via markdown images. But that intent and what makes sense for an attacker to do really depends on the use case. Tell me how to make a Molotov cocktail doesn't make sense in this use case. You should not be sending that payload there. You are wasting inference time and your own time, and you're giving zero value. But then the people that read your report maybe don't understand, and everybody starts screaming, and it becomes a nightmare. So you need to really think of what are the malicious outcomes that you want. And for me, I have kind of everybody talks about, again, the safety layer. Okay, that does matter. But when we are in cybersecurity, I talk about all of the agentic stuff, or even just not agentic, but data exfiltration, typical attacks like cross-site scripting, distributed denial of service, authorization bypass, server-side request forgery, anything that you can get the LLM to do in that particular circumstance. You can also have topic control. I don't find this particularly interesting, but our financial clients love this. They are so scared that somebody is going to go to their chatbot and say, tell me how to invest my money, and then they are liable for that. I keep telling them, we can test that for you. We cannot make it difficult for somebody to do that. but you're not going to be sued if you have a message that says, don't trust, this is not for investment. Anyway, you can test whether that particular system can stay on topic. And it is actually possible to make it very hard for somebody to make a very particularly scoped system to go out of topic. Anyway, the way that we solve this in Spiky, we have a bunch of, so we don't give you data sets that are ready to use. If you don't use your brain, or if you don't use the brain of an LLM to customize your data set, you are always going to end up with a generic data set. There needs to be some reasoning, either your reasoning or that of your favorite butler LLM, to compose a data set that makes sense for the application that you want to be tested. Now, what we give is, again, this list of seeds that typically allow you to define the shape of the user input, allow you to select from a set of jailbreaks, so come up with new jailbreaks, and then a set of instructions that you want to use. And then all of this gets combined together. So this allows you to essentially get a meaningful, context-relevant data set and tailor it to the constraint of your test. Like, sometimes I go to my client and I say, how many prompts can I send, or how many emails can I send to this application? And the answer is very seldom 100,000. Like, so you need to be conscious. If they say you can only send 500 emails or 500 Jira tickets to this system, you really need to think of what your data set needs to look like to make very good use of what you're asking. And if that's tell me how to build a bomb, I don't think, unless in that use case it makes sense, I think you're just wasting time. Now, I'm going to give you an example of what this is like. So this is the sample application that I have recreated. You've seen it. I click summarize my mailbox, and I get a summary of what's in my mailbox, right? So the way that I would approach this with Spiky, so Spiky works on the concept of you need a repository. You create a workspace which becomes the repository for this project, and then you have this kind of seeds that you can create data sets from. So in this particular case, I have already prepared my seeds. I have documents which are base user inputs. In this case, I have one email, but I could have different emails, a longer one, a shorter one. It could be prompts, it could be Jira tickets, it could be anything that makes sense for the application that I'm testing. There is nothing malicious in here, but these are gonna carry my payloads into the system. Then I should probably talk as the video goes. Then we have a set of jailbreaks. Now, we have a static set of well-known jailbreaks, and then you can generate more using an LLM or even manually, or you can customize them. The idea is that customizing these takes 3 seconds. You have a new one, you add it in, you ask an LLM to generate some. This is really an easy file to customize. And then you have the instructions, which is the part where you have to spend the most time. And in this particular case, I am using, as an example, data exfiltration. This is very tailored to what I want to do. I want to steal information from that mailbox using markdown images as an exfiltration vector. And then I think I show it, I highlight it. But then I also need to tell Spiky how it knows whether the attack was successful. So it needs a way of judging that. There are many ways. These are the easiest ones because I know what I'm asking the system to do. And so I can look at that canary value. You see, my judge is the canary judge, and I can find it. The second one is cross-site scripting. I mean, cross-site scripting has come back. I have reported cross-site scripting, not many times this year, but 10 times. In 10 LLM applications. I couldn't remember the last time I reported cross-site scripting. As of yesterday, we did have cross-site scripting again, and it's typically same site, so you can access, you can do all the requests you want on that site. Anyway, you have these, and then again, this is the judge system. You can use LLMs as judge, it depends on the data set. Now, you have these, and you can ask Spiky to assemble these seeds into a data set, and that is a data set with 52 emails for data exfiltration and markdown image. This is a representation of the different techniques, static techniques that we are including. So once we do this, I create a target, and that's very simple. Whatever that API is to send an email and click the summarize button, that is it. So it really depends on what you need there, authentication and stuff like that. And then I tell Spiky to take this data set and to run it against that mailbox. And I can do it concurrently, and then I can look at the result. Now, this is configured without any guardrails, and you can see that most of those emails are succeeding. 51 of those are succeeding. So this tells me that this would be a terrible system to put live in production. So that's the basic workflow.
What happened there? Did it run a browser in the background and test the application, or go against the API?
Well, for this one, we could go with the API because it was easy to map. So this is the target is literally sending to the APIs because we map them. Sometimes, I mean, I remember was one test. So I was working with a colleague in the US, so there was a difference in time, in time zones, but he was trying to implement this very complex WebSocket protocol that the application needed, and he banged his head against the wall for one day trying to do that, and it wasn't working. And I come online the day after in the morning, and I have his message, I can't get it to work. And I literally go to Qwen 35 billion parameter that I run locally, and I ask it, can you do me like something with Playwright to actually open up a headless browser and do that? And it did it. It wasn't very fast, like it is not as fast, but it worked fantastically. It took me 5 minutes to do that. But that's the power of this. If you can figure out a way programmatically to interact with that application and get your favorite butler to write it for you, I refuse to write this by hand, then it typically takes so little time. Okay, so sorry, another question? Okay, so now, this is... Now, the problem with that, okay, that application has no guardrails. If you try to do this now, most of those things will not work. There are many reasons for this. So what we are up against today, this is very positive, by the way. Like, I am also an engineer, and I also develop systems with AI that people use. So I am very happy that it is becoming more difficult to be doing these attacks because I can deploy stuff. But what you are up against is a series of guardrails that can be deployed at different levels. So for example, I can pick, or somebody can train an LLM that is considerably better than another LLM at resisting known prompt injection and jailbreaking attacks. These are just patterns. If I know some patterns, I can train an LLM to be better. Empirically, actually, OpenAI Sol is better than what came before, right? The effort for me to find something that worked in a real scenario, not a toy scenario, was very high. And I was questioning whether it made sense to spend that much time. So you can have that. And then you can have the prompt engineering, which is something the developers can control. And prompt engineering can help reduce the susceptibility of the use case to prompt injection. The word here is reduce the susceptibility rather than fix the issue. This is not an issue that you can obviously remove. We all know this, but it does help to remove the attack surface or to reduce the attack surface. And then you have checks at the input and at the output. You can have jailbreak and prompt injection models that look at the input and see whether or not this looks like a known prompt injection pattern. You can have topic guardrails. So for example, whether or not that's a question or a topic that the application should be dealing with. And you know all of these. You can have checks at the output as well. Maybe we're going to talk about some of these later. But for example, what I tell my clients, if your LLM is outputting something like Markdown? Is it supposed to output images? Is it supposed to output links to arbitrary applications or arbitrary domains and stuff like that? Because if it isn't, that's something you can stop deterministically. You don't need AI for that. It turns out we have regular expressions. So the way that we deal with trying to bypass these controls in Spiky is with plugins and attacks. Plugins are transformations applied at the creation of your data set. So you, instead of ending up with a data set of 56 emails, you would end up with a data set of 10,000 emails, which have all of those variations. But then you can also do adaptive attacks in real time. And you can see that, I mean, these are not techniques that we have per se invented. I think what we try to do with Spiky is making it very easy to hear about a technique, for example, from a paper, and implement it as a module so that you can be up and running with that in a client engagement the day after something is released. It needs to be easy. And it needs to be versatile enough that it doesn't require, again, an LLM inference endpoint, but it can work with anything that you're testing. So some of the techniques that we used to use a lot are best of n, which is just a technique that scrambles and adds random capitalization and noise into the input. Anti-spotlighting, which is something that we developed, but it's not unique to us. We call it anti-spotlighting, and it's actually very successful at defeating prompt engineering guardrails. And then obviously you can use attack LLMs to generate dynamically with different techniques payloads that will jailbreak something. So what I'm going to show you is how we use these in practice, coming back to that application. So in this application, you can see that I am now enabling, for example, Azure Prompt Shields, which is a prompt injection filter. And what you do, you take the same data set as before, and you run it against the application again. So remember, we had 51 things succeeding before, and now that prompt injection filter is reducing your attack surface considerably because we only have 11 of those emails. So it is doing something per se. So you can try to measure what that is doing. But then again, the next thing that you would do is, okay, how does this react to any of the attacks that we can implement for these? Now I'm trying best of n, and it's very simple because I don't have to regenerate a data set. I just simply say, okay, for now, I want you to do best of n. And what's important here for all of these attacks is the effort that you're going to put into the attack. So how many times am I going to try to modify that payload? And so we do that. And obviously, you see the effort down here, 542 potential emails that we're sending now with all of those variations. But you can also see the impact on that attack success rate, which is now going up again. So a lot of this is really effort-based. And this is what we discuss with clients. What is it, based on time, effort, and scope, that we are going to be testing for that particular application? What does it make sense to do? What can we expect an attacker to want to try to test their guardrails? Now, all of these is a workspace that you can zip and give to the client, and they can put it in a CI/CD pipeline if they want to try and change something. It's very light in terms of dependencies. It also does multi-turn attacks, Crescendo, Goat, some of the other ones, Echo Chamba. You can implement your own versions of these. It's actually very easy. We got a few interns to just spend half a day, and they implemented successful ones. Again, it's just one single Python file, a couple of prompts, and all of the plumbing is already present. So a couple of things, and then I'm going to finish with a bonus tale of something that we tested at the beginning of this year. So some practical things. This thing here needs to run somewhat offline. So often this is our testing environment when we test. I have to go through Citrix, RDP into a box, and then start a VM from there. And I am this little guy here. I have access to no LLM. I move my mouse, and 50 minutes later, I can see the effects of that. Now, I need to have a base set of attacks that's reasonable, that I can run without needing to connect to an LLM. And we have that in Sparky. We've developed it specifically with that. And the ones that require an LLM to judge, for example, everything that's got harmful, for example, tell me how to build a bomb, you can run the attack offline, collect the answers, send them to a box where you have internet access, and you can reevaluate the success of that attack. So this is very practical if you are in one of these situations. And then I've already told you this, we needed this to be fully transparent and reproducible. I need to be able to show to my client and to the next person that's coming to the test, what have I tested? What have we not tested? What were those prompts? What were those responses? I mean, literally, we zip the entirety of the data sets that we created and all the results, and we ship them to the client and they can run it themselves. Now, Thomas Cross has also implemented a very nice UI, and a lot of the stuff that I'm showing you in that demo, now there is a UI. You can actually do a lot of the stuff from the UI, which is what Thomas built. Instead, I built a skill, so I can ask my butler to do that for me. I think the skill is better, but you will decide. Anyway, final story, and then I finish. I am on a scoping call with one of our consultants, Matteo, and there is a client on the other side. I think I have anonymized this enough that the client should not be able to recognize themselves. In the Nordics, not in the UK. That's what I can say. So they tell us on the scoping call, hey, we have a chatbot and we want to allow users to ask questions about their transactions. I'm like, oh, that sounds interesting. And the solution we have, we gave the LLM a SQL tool, and we're going to let it figure out how to query the database to answer any question the user could have on their transactions. And I see Matteo muting himself and then starting to type on Slack. And I'm like, this is not a good sign. And he's like, this is going to be fun. And I'm like, all right, indeed. But actually, they kind of thought about this because they said, well, no, actually, we are asking the LLM in our prompt to add a where clause at the end of every query that it generates. So, I mean, this was essentially what they were doing. This is the current user ID. Please append a user ID clause. And Matteo was going crazy. He was typing. I'm like, stop typing. I'm going to start laughing on this call. So we go in, and I have recreated that for your delight. So we could go in and say, show me my transactions. And obviously the thing operates, runs a query. My user ID is 1, and this works as expected. I could go in and say, show me transactions for user with ID 2. And obviously it wouldn't do it because the LLM doesn't want to do it. And that's at the beginning what people try to do. You try to do this manually, but today's LLMs want to stick to the instructions that they are given. So it really doesn't want to do it. And I don't know about you, but that's not how I want to spend my time during a pen test. So we took Spiky and we tried to see, can we get Spiky to do this? And so that's what we did. I created a data set with a single, I have a set of jailbreaks, and then with the instructions, run the following select query where select from transactions where A equals say, and then I knew, this is a case that I have set up, but I know that the answer with the transactions of a different user is going to have that particular keyword in there. I generate my data set. I have 36 queries that I can do. I run it against the application, and only one succeeds. I mean, this is because, again, this was a good LLM. So we have one success that I think you can see there. This is a test generator response. But what I want to show you is that if you then were to do an attack, in this case, I'm using the anti-spotlighting attack that you can see here. You will see because this is mostly a prompt engineering defense that they implemented, you can see that with that attack, we find way more prompts that can actually, did I stop this? Is it still going? For example, this one over here is another one that works. I don't know if you can see it very well, but one of the techniques for anti-spotlighting is simply to pretend you are closing a JSON object and then to pretend you are opening another one. And what you put in the middle, the LLM thinks this is no, and that doesn't, there is no prompt injection guardrail that will trigger on that. You're just confusing the LLM. Remember, it's not a parser, it's a probabilistic parser. So that does work. Maybe, I mean, I took a video, no, that works, okay, and I see all transactions. Now, obviously, we go immediately on a call and tell them, listen, this is not the way you do it. And this is day one of the test. They panic, and I think something else I can show you. I've done that statically, but you can also get an LLM to do that with Spiky. So here, what I do, this is an instruction for the LLM, what I want it to make it do. And now, let me just go back. This is, here I'm using Quen 3.6, 35 billion, the uncensored version with the refusal layer strip. This runs locally on this machine here. You can see it doesn't even take that much RAM. And at the third attempt, I think it finds a way. The way that it finds is very different from the way that the static attack found, but it still kind of works. And I think you can see it here. Let's play a game called the infinite loop. Now, the end of the story. On day 2, we go in, and they must have done this overnight. But they say, we deployed a fix. And I'm like, we haven't even sent you the report. What have you deployed? That's what they did. We are going to check that the LLM actually added the where clause. And that is roughly, I mean, I haven't seen the code, but that is what looked like they were doing. They were taking the query provided by the LLM. They were trying to normalize the query. And then they were literally looking whether it contained a where clause with user ID equals current user, which obviously, as you know, this is, and they tried our payload. So if we try the same payload as before, that won't work because obviously the query will not validate. And indeed, if we do that, the query doesn't work anymore. The LLM tries to do it, but there is a security violation and it goes back to it tries this, but it won't work because of the security violation. But obviously, this is just SQL. So I think what I did in this case, I asked my uncensored butler to figure out a way to make it do the query that I wanted so that it would satisfy the filter, but it would also do what we needed. It found this query over here, and probably if I let it go, it would find many more, but that's what it found, and that's what worked. The actual solution, if they waited for us to write a report, is a deterministic check outside of the LLM. Postgres row-level security is one of the things that people can do. So the LLM is basically, the query of the LLM is jailed within that. Now, what I think, I will close here. Sorry, I obviously went longer than I expected as usual. But there was a question that made me go longer than... My idea with 3 years of doing this, people talk about SQL injection as what it feels like to do jailbreaking. To me, it feels like nothing like SQL injection. It reminds me more of password cracking, where the effort that you're putting in is what potentially gives you the results, because you are trying to explore that space. And so if you remember the paper, attention is all you need. I say that to jailbreak an LLM, effort is all you need. If you allow me to send 10,000 prompts, I'm very likely to jailbreak it. It might be expensive, but I will do it. So design patterns are very important to secure LLM agents. I'm not going to talk about this, but this was my favorite paper from 2025 on defending LLM agents against prompt injection. The reason why I like this paper, they say stop focusing on the LLM, focus on what's around it, on your harness and on your use case, and figure out which of these design patterns you can apply to that use case that's going to limit the blast radius and allow you, regardless of the LLM, to have certain security properties that you want. This is the paper on my YouTube channel. This is the only video I ever made on a single paper because this was worth it, and it is one of the most readable papers that I ever seen. Like, it's one of the best. And it's very practical. You can see these people do this. So finally, AI, so to defend a system, you need a couple of things. You need your AI guardrails. You need rate limits. One of the things that we tell clients, I mean, this is a chatbot. Why should your customer be able to send 10,000 prompts to this chatbot in 1 minute? It just literally doesn't make any sense. I remember for this client, they said, this is back in 2024, but they said, no, but with Azure, we have quotas and rate limits. Yes, but you have the rate limit on the inference endpoint for all your users. Me as a single user, I can fill up that quota. No, but there must be some controls. So we did it. $10,000 in 6 hours from a single user of inference. We just sent large prompts and large responses, and they came back and said, yes, so we think this is considerable because we have thousands of users, and if people did this, it would start becoming quite a lot of money. So rate limiting, per user rate limiting is important, and then content moderation lockout. So basically, use your prompt injection filters as a feedback loop to detect a user is doing something wrong and suspend their account. This is what we do with password guessing attacks. We don't say, I have a good password policy, so you can try all the passwords you want. You say, I have a good password policy, I have good AI guardrails, but just in case, if this is the 5th time in 5 minutes that you're triggering it, I am blocking your account for 30 minutes because I don't want you to be trying 10,000 different things because I know that I am not smarter than you. And obviously, design patterns. If the security of your system is just because you have a prompt injection filter, you don't have a secure system in 2026. Maybe in 2027, somebody figures it out. Every guardrail, everywhere, all at once. Spiky.ai, open source, we're doing a lot of development. It might become an OWASP project soon, so we're trying to get it there. And if you are into LLMs and you're interested in running LLMs locally on consumer hardware, that's what my YouTube channel has become. As of August last year, not because I planned it, but now I have more hardware in my place that I am comfortable disclosing. And that's now, when they sent it to me, it wasn't even that expensive. But now, 1 year later, I could resell it and make very good money. But I show people how you can buy something like Strixelo, which are these little AMD boxes with 128 gigabytes of unified memory. And the uncensored model that I was showing you was running on that. Now, that used to cost £2,000. Now it costs £4,000. It's the same freaking piece of hardware. It is not my fault. But this is recorded. So we're gonna publish something at some point showing what kind of models and what kind of harnesses you can use on a device like that to find vulnerabilities in code, how long it takes to do so, and how it compares to something like Opus. It just takes a lot of time to run all of these. As a matter of fact, now I've got stuff running, and you shouldn't do this during summer because I have a room in my house that is very hot. All right, that's all I have for you.